Okay, practice problem 4. Monica says the function is linear. So Monica, linear, because the rate of change increases by 1 for every step. So she's saying the rate of change is constant, and it seems like she's saying the rate of change is 1. Do you agree or disagree? Why? All right, let's go ahead and do this 3 times. Slope number 1. I am going to use the first 2 points. Why not? I'm going to call this x1 and 2, y1 and 2. When I plug them in, I get 4 minus 0 over 2 minus 0. So that's 4 over 2, which reduces to 2 over 1. Okay? If she thinks the slope is 1, she's wrong, but maybe I'm reading that wrong. So let's choose a different color. Choose our different points. I'm going to use 4 and 6. So this will be my 1 and 2. 1 and 2. So for my slope number 2, when I plug it in, I get 15 minus 9 over 6 minus 4. 15 minus 9 is what? 6 over 2. So that is 3. I can stop here because I've got different slopes. So I know it cannot be linear. So Monica is wrong. So I disagree with Monica. Make sure you answer the question. I disagree with that girl because the rate of change is not constant. So, can't be linear. Monica's wrong. The slope changes. So, that's it. Okay, practice problem, whatever, I can't keep up. So, is this linear? Explain. You know the deal. We're finding slope 3 times. We're going to use these first. Yes, there's integers. Maybe I don't want integers, actually. Let's be smart about this. Maybe I don't need those. So let's start here, okay? Work smarter, not harder. So I'm going to do x1, x2, y1, y2, slope number 1. And just so, I just can't help it, guys. I got to write it every time. So I'm going to do 6 minus 4 over 1 minus 0 to get a slope of 2 over 1. All right. Switch colors. Now I'm going to use these 2 points. Call this x1 and 2, y1 and 2. So my second slope is 10 minus 8 over 3 minus 2. Okay, I got 2 minus 1. We're looking good. I'm going to switch colors. And I got to pick 2 other points. So I'm trying to avoid those integers. So I'm going to go like this. I'm going to do this one right here. Okay, so for my slope number 3, I'm going to have 10 minus 8. And no, I'm not. I'm going to have 10 minus 6. Sorry. See? That's why you got to label it, you guys. Let me label it. This is going to be x1, y1, and then this up here will be x2, y2. Okay, start over. Y2 minus y1 is actually, I messed up, is actually, what's my y2? 6 minus 10, and my x2 is 1 minus 3. Ew, they're negatives. I should have changed the order, but that's all right. This is a negative 4 over a negative 2, which actually ends up being 2 over 1. Now look, everything's the same. 2, 2, 2. But I feel like they put those other points up there for a reason. Like, I feel like they're trying to trick me. So I'm going to find slope a 4th time. Okay? I'm going to find slope a 4th time just to see. I got trust issues. So let's see. I'm going to use these. I don't like it, but I know how to use integers. I ain't scared. So I'm finding a fourth slope. And I'm going to get 2 minus 0. Okay, still 2. And I'm going to get negative 2 minus negative 4. So that gives me 2 over, this means plus, negative 2 plus 4 is 2. See, y'all? That's 1. They tried to trick us. So the rate of change, it's constant if you only look at the positive numbers on the table. But if you look at the entire table, you'll see that it's not. So the lesson here is, yes, you can be smart about the points you choose, but if you leave out entire ordered pairs, your information might not be accurate. So make sure you use every ordered pair at least once when you're finding your slopes. And that might mean you have to find 4 slopes or 5 slopes, depending on how much data they give you. Usually 3 is enough. 3 would have been enough if I hadn't tried to be slick right here and use this one. So to answer the question, the function is not linear. Because the rate of change isn't constant. Because the ROC is not constant. I'm going to set you up for how to do the next practice problem, because you're not going to know how to set up your table. So it says create a function table, determine if the equation is linear, and then check by graphing. So you have to do the table and you have to graph it. Now, you don't know how to do that, so let me just do it for you, okay? So you set up your table, the big table. X goes here, Y goes here. And in the middle is supposed to be everything that comes after the Y equals. But they have the Y on the wrong side, right? I don't need that +1 over there with it. So I'm going to get rid of that by subtracting 1 here. Let me get rid of this because it's confusing. Okay, and whatever I do on one side, I have to do on the other. Now, this is the thing you don't know how to do yet. I'm just showing you for, you know, the people that just need to know. So now my Y is by itself. And now I'm going to bring down a -1 and a +2x. Okay, for the sake of algebra, we do variables first. So in the middle, you're going to write 2x minus 1. Okay? If you don't understand what I did, don't worry about it. But this is what your table looks like. I'm telling you, you need to choose 3 x values. It doesn't really matter which x values you choose, but I usually go small, 0, 1, and 2. You're going to put your x values here, whatever you happen to choose. You're going to do the math in the middle. You're going to figure out your y. You're going to graph 3 points and connect the dots so that you can answer the question.